And please welcome our presenter, Jonathan Carroll. He is the Director of Learner Insights and Opportunities at Ed+ at ASU. Go ahead, Jonathan.
All right, thank you. And this is a 20-minute session, so we will go like lightning, and it'll be a quick overview, but hopefully one that will spark interest and conversations as we go down this road together. So this presentation is about server-side tag management, how we leverage Google Tag Manager, then integrated with the Google Cloud Platform to have more scalable behavioral data science and orchestration capabilities. Going from here, topics that we'll cover. One is what's the difference between client-side tag management and server-side tag management. Then two, how it provides a staging environment for data. Three, increased client-side performance. And four, now enables us to be a privacy-first approach. And so with this privacy-first approach to student behavior and data collection, collection of data is not new, but it's historically fragmented in how we get behavioral data from various different systems and sources. But now we are ushering a new era where we are doing it with a privacy-centric strategy. All right, and there's a lot more people coming in, so trying to manage the clicks. So here's the differences between server and client side. So with the student's expectation about who they engage with, they engage with other students, they engage with faculty, staff, and ASU resources. So when you're a student, great, I go into Canvas, I have my syllabus, curriculum, my PowerPoint to download, and some course lectures, and hopefully some VR if you're in one of those cool courses. But really, who you engage with is a lot more than just that. There's a lot of people that get to listen in, from our marketing vendors, from our CRMs, from our data warehouse environments, from our logging. There's a lot of people that listen and get to track what people do within our ecosystem. And so some people could say that's, maybe that's a violation of expectation, or don't understand the complexity that goes into student support. We use all these systems for a very good reason, but we need to be more transparent with it and allow the end user to choose how we use their data. So with tag management, we would previously just invoke custom JavaScript to load directly on a page to get the data that we need. And up to this time, it's served us well. It's how we've been able to grow, been able to scale ASU up to this point. But because capabilities are now online and user expectations have evolved, we need to be here to usher in this change and work with all units at ASU to migrate to this new server-side approach, which provides the benefits that we'll be talking about. Okay, so here's an example. So right now, too many organizations have maybe too much access to too much data just directly within our web environment. So when someone goes to Google and does a search for ASU, and then we load the website, we then load Google Tag Manager, and everything that is then designed to load upon page view also loads as well. So that can be Facebook script, it can be Google Analytics, it can be advertisers like Outbrain, DoubleClick, LinkedIn, our partners with higher education, etc. All of those take data that they need for their purpose. But ultimately, because we're invoking Facebook's JavaScript, we're invoking LinkedIn's JavaScript, ultimately they could do what they want. Now there's a lot of trust built in between us and these vendors, but now that's also evolving. So here's then what is like a server-side tag management. Once again, when you search for ASU and the website loads, Google Tag Manager loads, but none of those other scripts load. Data then does not go directly to Facebook from our website. Data does not go directly to Google from our website, etc. We're starting to have more control over every iota of data that goes to one of our vendors. So here's an example. So how this works. Generally, when you load Google Tag Manager, even that itself is calling resources from Google. But what actually happens is we are now proxying this environment, this tag management container on our own ASU domain to where then this library no longer is being called from googletagmanager.com. It's being called from SSTM for server-side tag management, sstm.online.asu.edu. So that's the first step of making sure that these libraries are not being called from third parties, but actually being called from our own. You can then whitelist exactly which GTM containers are able to be calling from our server, so nobody else can use it. So then from here, we're able to then uniform an event data object. So those that are familiar with Canvas Caliper or Canvas Livestream, even those two things from the same system spit out two different versions of data. Those that are then also use SIS data from PeopleSoft, a treasure trove of critical information. But again, the data is not standardized. Now that Google Tag Manager is on Canvas, that Google Tag Manager is on PeopleSoft, and that it's on my ASU, WP Carey, etc. We have the opportunity to have a standardized event data object to where any engagement that's occurring across ASU's digital ecosystem has the same event definitions. To where then, when there's data standardization, it enables us for quicker analysis and machine learning capabilities, because a big effort around data and analysis is cleaning it and preparing it. And now a lot of that is done on the front end. Okay. So then here also ensuring GA policy compliance. Google Analytics is a secure and certified environment, but per Google's policy, we do not store PII inside of Google's Analytics solution. So from there, we have the ability to override data that might come from the website into Google Analytics from all of our various data sources, to where if we know that we are collecting first name, we simply override it as undefined or redacted. And so client-side data the importance is growing as we start to understand the capabilities of student interventions in LMS communications, to where we don't have to rely on LTI integrations exclusively, to where you have to actually click on a portion of the navigation to actually launch an LTI. Because Google Tag Manager can load JavaScript anywhere at any time, we're able to engage with students in a completely different way. So this is providing a scalable, secure, and also dynamic environment to load intervention type engagements. Okay. So second, then, about staging environment for data. So what exactly does this mean? It ushers in a new level of control and governance because, once again, all the libraries and data are initially proxied on our domain. So two big points. One, the browsers do not speak directly to third-party vendors. And two, data is enriched using server resources, not the browser. So regarding the first point, if, for heaven forbid, Facebook was hacked, and then someone knew that Facebook's JavaScript was on our website, then they could potentially get into our environments. Now, because we are completely removing any notion of Facebook on our website, that's then technically impossible, because no longer does a Facebook network call derive or come from our website. Second, then, is we do a lot of data initiatives at ASU. There's a lot of people on this call, a lot of people elsewhere around the university that access data. For example, just with Google Analytics alone, there's over about 525 people who have access just to the enterprise, not just your own, but to the enterprise GA instance. So the more things that we put on a website, the slower it's going to run. Now, because all of this data enrichment and data logic is no longer happening on someone's device, it's happening inside the Google Cloud Platform. That means we're able to have the power of a cloud platform like Google, but also the nimbleness and how light of an experience we have for the end user, because no longer is that actually occurring on someone's browser or their machine. So here's an example of where we're at and also where we're going. Take one of the assets that EdPlus manages, the ASU Online website. On every single page view, there are 25 scripts that load from within Google Ads, Microsoft Ads, Facebook, DoubleClick, custom scripts, Google Optimize, etc. 25 different things load every single page view. But now where we're going to is just one. just one GA4 configuration tag that sends all data to our server. So this GA4 tag still is not calling Google's resources. This never talks back to a Google server at this point because it's being proxied from our own domain. So how exactly does this work? So the client-side Google Tag Manager calls a library from ASU server-side Google Tag Manager App Engine on GCP. And then the GCP then GTM loads gtag.js library from our own ASU servers. So still no data, no network is leaving the ASU environment. Then on the third row, the page view and or events are tracked with network calls pointing to an ASU server, not to Google's. And then from there, then ASU server-side GTM administrators are able to enrich and orchestrate exactly what data do we want to go to Google, exactly what data do we want to go to Facebook. Because if given the ability, those the awesome technology partners and platforms will take more data than what's needed for our own purposes, but maybe used for something else that they need. So this is going to address a big thing. Once again, going from 25 different things loading down to just one. Being open, this is going to greatly increase page performance by decreasing the amount of time it takes for a page to load. With third-party code taking up a majority of what is being loaded on a website. So how exactly are we able to do this? Here are 3 examples of 3 different network calls. One from the Universal Google Analytics object product, one from GA4, and another from Facebook. You'll see that these things are different, right? Where exactly are we trying to send data to? Then here you'll see then different parameters of data are actually consistent. DL, DL, and DL. They're asking for the same thing. CID, both whether it's Universal Analytics or GA4, the identity of the individual as defined by Google is the same, but then maybe something's unique to Facebook. So there is some uniqueness, but to a lot of what they're asking for, it's the same. So then what we do then is have a single network call of GA4, but then, so GA4 natively gets exactly what it needs, but then we append that network call with everything that all of our other vendors need as well. So in that way, we're able to simply just have one network call, not 25 different network calls, which those network calls having 80% the exact same data. So we're reducing the load and requirements on the browser and the user device by simply having one network call. So then now we'll go into privacy first. Something as simple as redacting a visitor IP address. We do send a visitor's IP address into Google Analytics servers to be able to identify geo-based location. But now, because we're still working at this point within the Google Cloud Platform, which if you trust, AWS is your platform, if you trust Azure is your own platform, if then also likewise with GCP, we're able to then use Google's own Maps API to take the IP address, find the geolocation information, and then append that to where then Google Analytics does not get the IP address of the user. We say, Google, we know that you use it to get their geo data, but it's totally fine. We're going to give it to you anyways and not give you the IP address. So that's where we're going there too as well. So here, go deeper into that. So with this, we're able to remove the IP address and user agent to still get the same level of data insights that we need, but still increasing our level of anonymity to our end user. So like with IP address, we redact that, but get the geo-based locations based upon their GCP resources, and also user agent. Another way to fingerprint, we can, and for that, we need, I think it's open for discussion. People can use it for fingerprinting, but stuff that comes from user agent is stuff like your browser configurations, your how many pixels are on your monitor, what type of machine do you have. This is incredibly helpful data for those that really invest in QA, for the Ed Plus QA team to be able to understand when there are issues with the user experience, to identify what browser were they on, what device were they using, etc. That's incredibly valuable. But But those are two things that we can definitely redact while still maintaining a high level of insights. And then also, lastly, then we can still maintain the directory level identifiers that we use, like the EMPL ID, Canvas user ID, Salesforce IDs, etc. So here's an example. So when we restrict third-party data collection, here's an example on the left, exactly what Facebook is scraping. Now, a common use case is, say when a current student enrolls or signs up for an event at Gamage, or when they sign up for a TEDx talk, if you use the Eventtree platform. When you load the Facebook pixel, this is what they're collecting upon page load. Now, I know it's small and you'll get this deck, I'm sure, as a follow-up, but they're collecting a lot of information that's not necessarily pertinent to what we want Facebook to do for us. Now, Facebook uses this data to get more insights about the individual. So then that way, maybe if we down the road, but then also other educational advertisers want to find people who are behaving with higher ed companies in a certain way, they have more information, which we no longer need to do this. And I would say we shouldn't be doing this. So with the server-side data-given approach, we're able to then still maintain the level of data that we need to have for our end platforms, but only including the very specific data that we need for our specific use case. We no longer need to simply let Facebook page scrape grab everything, then within the Facebook platform, then say, okay, well, what things do I actually need to use? That conversation and that decision needs to happen within the ASU before we even send the data over to our end platform. Okay. So here, with a summary, what we're doing here with this migration is, one, this enables ASU to own more of the data processing because it's happening within our own ASU server hosted on the Google Cloud platform. Two, it reduces the client-side bloat and improves performance. Using the ASU Online website as example, we're removing those 25 things that load upon every single page view and reducing it only to one. So it'll be a much better user experience because it'll be a lot quicker one. Three, enable us to have a privacy-first data collection approach, to where, as UTO's Information Security Office helps drive and lead conversations around user consent, regardless of data source, if it's coming from client, if it's coming from server sources, how do we process it and what do we do with their data? Server side allows us to have a lot more to honor and to respect, to be more dynamic to those changing requirements. Four, this improves data governance and ownership, because no longer are we loading Google's libraries directly on our website. No longer are we loading LinkedIn. We're first sending all of our data into our own ASU server, and then sending only what we need for our business purpose down to our end systems. Five, heaven forbid something needed to be audited, because all this is built off of GCP's App Engine. Every single incoming data and every single thing that we send out is being logged, to where then we can query that if needs be. Then six, between the synergies between what we're doing on the Google Marketing Platform and then data science on the Google Cloud Platform, the Google Tag Manager server container being built off of GCP natively, then just enables greater synergies between what we can do. Maybe some things like down the road, when we are mature enough, what do we use Google Analytics for? Do we want to write straight to BigQuery without having to use GA? Now that's an option. And when we have additional data within GCP, before we send it to Google Analytics, we can enrich it with a different data set elsewhere and pre-append it before we send it off into another environment. So this was a quick overview of where we're going with server-side tag management and where we're migrating. I want to just see if there are additional questions before I can give some additional context, maybe a demo into what it looks like.
Well, it looks like we're pretty much close to time. So thank you to our presenter, Jonathan, and thank you all for joining us on this session.